Today we're going to take a look at how to calculate expected values and how to use them to calculate the chi-squared, and then how to implement the test for dependence to relate two different variables together. Let's get started. To begin with, the chi-squared test is used to find if two classifications from the same sample are independent. So what that means is, does the occurrence of one of them affect the occurrence of the other one? Is there anything that relates two different variables together, or are they completely independent, which means the occurrence of one has no effect on the occurrence of other? That's what we're going to do when we calculate our chi-squared and run the chi-squared test for independence. In order to run the chi-squared test, we're going to observe the difference between the observed frequencies and the expected frequencies. The observed frequencies are going to be denoted as f sub o, O standing for observed, and the expected frequencies are going to be f sub e, where e stands for expected. In order to calculate chi-squared, we have the following formula, where chi-squared is equal to the sum of the observed values minus the expected values squared divided by the expected values. So what this formula means is we're going to have to perform this process for each different set of observed and expected values. And we'll talk about more about what this means and how to find this in the following steps. The first thing we want to do though is calculate our expected values. So we're going to discuss how to do that now. For a chi-squared test, your data is going to be organized into a table where you have rows and you have columns. So looking at our information here, we have two rows and we have two columns. A, B, C, and D represent the actual observed data, the numbers you're given to. W is the sum for the first row. So we could say that A plus B equals W. X is the sum of the second row. So we could also say that C plus D is equal to X. Similarly, Y and Z are the sums of our two columns. So we could say that A plus C is going to equal Y, and B plus D is going to equal Z. Now when calculating our expected values, it's important that we understand that we're using these sums. So we'll be using just the W, the X, the Y, the Z, and then the N, which represents the total number of people in the study, or objects. And again, we find those sums by adding the rows or by adding the columns. So the observed values are the ones that are given to you from the original study. The expected values, or the expected frequencies, are what we would expect to happen if we repeated this experiment a second time, or a third time, or multiple times afterwards. To calculate your expected frequencies, what you think would happen, you're going to be multiplying the sums of the row and column that a certain number is in. So if I want to know the expected value for this box here, then I multiply the sum of the row, which is W, times the sum of the column, which is Y, and we divide by the total number. So we always have that pattern where it's always the sum of the row times the sum of the column for the number we're looking at divided by n. If we look down here, we have x times z over n because x is the sum of the second row, z is the sum of the second column, and we're always dividing by n. We're going to go ahead and apply this to find some expected values for an experiment. So for our study, the table shows the results of a sample of 400 randomly selected adults, and we classified them by gender and if they exercise regularly or not. So to begin with, let's interpret our data. We can say that there are 112 males who regularly exercise. There are 104 males who do not regularly exercise, and there's a total of 216 males in the study. We have the same descriptions for our females. There are 96 females who regularly exercise, 88 females who do not regularly exercise, and 184 total females. And then going down, 192 people who do not regularly exercise, and 208 people who do regularly exercise. So these are the actual data. This is how it's classified. What we want to do now is figure out what would the numbers look like if we did this experiment again. What would we expect these four numbers to be? And we're going to calculate those using the formula from the last table and our sums from this table. Alright, so here we have the process of finding our expected values. To find the expected value of the amount of males who regularly exercise, we take the sum for that row, 216, and multiply by the sum of that column, which is 208. We're then going to divide by the total amount, which is 400. And we repeat this process for each number. So looking at the amount of males who did not regularly exercise, again it's the sum of that row, 216, times the sum of our column, 192, and divide by 400. And we're repeating that process for the females as well. So we have 184 times 208 divided by 400 for our females that did not regularly exercise. And then we have 184 times 192 divided by 400 for the females that did not regularly exercise. And this will complete our expected values. Alright, so after we have calculated our values, we have 112.3, 103.7, 95.7, and 88.3. Now it's important to note two things about our numbers. Yes, we have decimals for people, and it might not be appropriate, so we could round up or down depending on our values. But when you're calculating chi-squared, you want to be exact as possible, so you want to use approximate decimals when you're calculating it. The other thing that's important to note here is that your rows always add to be the sum. So if we added 112.3 plus 103.7, we get 216. Same thing for our females, and it works down for your columns as well. So your rows and columns will always add to be your sums. If they do not, then you have miscalculated one of your expected values. Now that we have our expected values, we can plug those in with the observed values to find chi-squared. But we're going to practice finding some more expected values. Let's do some more examples. For our next example, we had a study that recorded if you watched The Walking Dead or did not, and then if you identified yourself as a male or female. And we have the following expected values. So we don't have the original values here, but we do know that we expected 91.8 males to not watch The Walking Dead and 107 female to watch The Walking Dead. Using the ideas that the rows and columns always add to be the sums, I want you to quickly identify what A and C are and select the correct answers. Alright, here we have another example. We have a study that asks if people like to listen to Justin Bieber or do not, and again if they identified as a male or female. I want you to use the formula to calculate A, B, and C. Again, the formula is the sum of the row times the sum of the column divided by the total number in the survey. So go ahead and identify A, B, and C correctly. Alright, now we're back to our original problem about exercising regularly and not regularly exercising. Now that we have the expected values for those, we're going to use those combined with the observed values to calculate chi-squared. And then we'll talk about how to interpret it. Alright, so now in order to calculate chi-squared, we're going to use our formula here. So we have the observed minus the expected squared divided by the expected. So for my first formula, it would be 112 minus 112.3 squared divided by 112.3. And that gets me a very small number. It's approximately 0.00080. If we repeat that process for our next set of numbers, then we have 104 minus 103.7 squared divided by 103.7. And again, we have a very small number, 0.00087 approximately. And if we continue this for our remaining two expected and observed values, then we get 0.0094, and 0.00101. Adding those all together gets us our chi-squared value, which is 0.00362. And now that we have a chi-squared, we can interpret what it means. Alright, so our goal was to determine is there a relationship between the identified gender and then regularly exercising. And since our chi-squared was small, then we'd say that there is a close agreement between the observed and expected values, which means that regular exercise and gender are independent factors. So that was the whole point. Are they independent or are they not independent? Now because of our chi-squared value, we can say that they are independent. We will talk a lot more about interpreting chi-squared in the next video. Tomorrow we're going to focus on calculating expected values and calculating chi-squared. Before we finish our video, I'm going to do one more example. So at this point, if you feel comfortable with calculating the expected values and chi-squared, you can turn off the video. But I'm going to do one more example of finding the expected values and finding chi-squared. So if you want to watch those, go ahead and continue playing the video. Alright, so for our study here, the table demonstrates or shows the results of a sample of 85 different students who were asked if they wanted to change their schedule for the school or not. They're broken down by the response. So C means that they do want to change, and the C of prime, the apostrophe C down here, means they did not want to change. And then we had their class level, 9th, 10th, 11th, or 12th grade. So here again we have the observed values, the actual responses. So there were 7th, 9th graders who said that they wanted to change. There were 14 12th graders who said they wanted to change, and so on. And now we're going to use these sums, so 43, 42, and then sums down here, to help us calculate the expected values. If you want to go ahead and practice that now, hit pause. On the next slide I will show you what the expected values are. Okay, so here we have our expected values. Again, the way that we find them is we're going to multiply the sum of the row times the sum of the column and divide by the total. So for my first 10.6, it is 43 for the sum of the row times 21, which is the sum of the column, divided by 85. For our second 10.6 is again 43 times 21 divided by 85. And we have some repetition here because a lot of our sums down here are the same. So we can see one more time down here for 12th graders. Again, it's 10.6 because it's 43 times 21 divided by 85. Now that we have our expected frequencies, we can use them to help us figure out our chi-squared. So let's look on the next slide. Alright, so here we have our observed values and the expected values, and then I've calculated the number to help us get chi-squared. So for our formula, once again, we have the observed minus the expected divided by the expected. For my first example, or for my first number there, it would be 7 minus 10.6 squared divided by 10.6, and that's how I got 1.223. Moving down, for my next number, it would be 9 minus 10.6 squared divided by 10.6. And we continue that pattern for the rest of our numbers, always using our formula of observed minus expected squared divided by the expected. Once we add them all up, the number at the very bottom, the sum of all of those gives us our actual chi-squared value. This time it is significantly larger, it's 5.816, and so we would compare that to what is called the critical values table to determine if our sample is independent or not. We'll be discussing the critical values table in tomorrow's video as well, but for today the focus was to make sure that we understood how to find the expected values and then how to use them to plug into our formula and then get our chi-squared value. Alright, so this completes our video for today. Again, tomorrow we're going to focus on calculating expected values and identifying chi-squared. See you in class.